this house to interview some of the engineer personnel to ask them about pervaporation. Nizam, can you give some insight about pervaporation definition?
Oh yes, of course. Okay. Pervaporation or pervaporative separation is a process method for the separation of mixture of liquid by partial vaporization through a non-porous or porous membrane.
Thank you for your insight, Nizam. So we are going to interview Jay, one of the best engineer that we have. Okay, Jay, can you give some insight about characteristic of pervaporation?
Okay, there are 4 characteristics of pervaporation. Firstly, the process uses low energy. Second, as entrants are not required, there is no contamination in the system. Third, the equilibrium of vapor and liquid does not interfere on the process of function. And fourth, the lastly is when operating, the permeate need to be volatile.
Thank you for the insight given by Jay, the most experienced engineer that we have. Okay, Pata, can you explain about mechanism of pervaporation?
The pervaporation can be operated in distinct flow process, which is batch and continuous process. During the process, the feed flow along one side of the membrane, while one of the components of the feed preferentially passes through the membrane. On the opposite side of the membrane, the permeate in the vapor phase, which is the phase has been changed from liquid to vapor. To ensure the continuous mass transport through the membrane, very low absolute pressure are maintained on the downstream side of the membrane by a sweeping gas or a vacuum operation.
He currently is on the internship program. Maybe he can give us some explanation about mechanism of separation. Ehsan, can you give us 3 fundamental processes in pervaporation?
Yeah, sure. So basically, there is a 3 mechanism of separation in pervaporation. The first one is sorption of permeate in the upstream surface of the membrane, and the second one is the diffusion of the permeate across the membrane matrix, and the third one, last but not least, is a desorption of the permeate into a vapor phase at the downstream phase of the membrane. So this is basically the mass transport. The mass transport across the membrane is usually governed by these 3 fundamental processes. So next one, we talked about the membranes just now, right? So there's 3 types of membranes. The first one, we call it as a hydrophilic. The second one, hydrophobic, and the last but not least is organophilic. So these 3 is differentiated by different function. The first one is hydrophilic, means it attracts water. So it attracts water. So to means that it attract water as the last products. So it can separate water from the recovered chemicals. And the hydrophobic itself means it's phobia with water. So it will separate the volatile organic components from water. And the last one is organophilic. Actually, we recover organic from solution, usually used to separate organic mixture with maybe like 2 or more components. So this is 3 types of membranes.
Ehsan, thank you for your explanation. So I'm going to interview one of the best student in engineering, chemical engineering. Firdaus, can you give me the explanation about membrane module involved in the pervaporation?
3 types of modules. The first is the plate and frame modules. It is the earliest modules, but since it is costly, it has been replaced, and it is usually most in a fouling condition. The second is the spiral wound modules. It contains several envelopes wrapped around a central collection pipe. It is designed to minimize the pressure drop. The third is the hollow fiber modules. It is able to pack a very large membrane into a single module. They come into a two main geometries. It is a shell-side feed. The shell-side feed is a loop or a closed bundle of fiber. The second is a bore-side feed. It is a fiber are open at the both end and the feed is circulated through the fiber. That's all. Thank you.
Thank you, Jimmy, for your explanation. So, Jay, can you explain about process involved in pervaporation?
Okay, there are two processes involved in pervaporation, which is batch process and continuous process. In batch process, feed solution is gathered into surge tank, whereupon some of the gathered solution is fed into a feed tank and circulated at a high velocity to the pervaporation modules until the desired concentration level has been reached, and there the treated water is then removed. Second, there is continuous process, which is the feed is preheated and passed to a membrane separation module in series, which each module in vacuum chamber that pumps incondensable fluids from the system while the permeate condense and move to the membrane. To keep at high removal efficiencies of the permeate, interstage heaters maintain heat of vaporization. Only that.
So, thank you, Jay, for your explanation.
I'm going to give you factors that are affecting pervaporation. So first of all, temperature. As temperature has an effect on partial pressures, which in turn affect the flux. Higher fluxes can be obtained at higher temperatures. So second one is selectivity. So the selectiveness of the desired permeate go through the membrane versus the other chemical in the solution. So this is typically done by controlling the size of the holes in the membrane. So the third one is feed concentration. Concentration of the preferred permeate in solution. Higher concentration generally means more of the solution moving through the and vice versa. Okay, the fourth one is membrane thickness, inversely proportional to the overall flux. The last one is partial pressure, providing the driving force of the moving permeate through the membrane. The higher pressure difference will force more molecules through. That's all. Thank you.
Last but not least, the application of pervaporation is dehydration of organic solvent, the removal of organic from aqueous stream. 3. Breaking isotope. 4. Dehydration of solvent and other dimethyl organic. 5. Organic separation such as ethanol or methanol removal. And last but not least, wastewater purification. So that's all from us. Thank you.
Let it go, make my body go. Make our bodies higher and higher.